Hi, Alex. I'm here with Alex Gouaillard, and I'm really excited actually to do this interview because Alex is a real expert in some of the things that make WebRTC work today, and we're going to get into that. I don't want to steal any thunder here, um, but I think probably the best way to start is just sort of with a little bit of background. I mean, you and I met a number of years ago at some of the WebRTC conferences and the standards work, and have known each other for a number of years now, and in a number of different contexts. But I don't know that necessarily my visitors to my site are going to know your background. So would you be willing to give us a little bit of your background as it relates to this space? I mean, you can talk about other stuff too, but I'm really kind of curious, how you got to this point. Not so much the specific work we're going to be talking about, but just in your life, how did you get to the WebRTC space?
Hi, Dan. Thank you for having me. Yeah, sure. I can go quickly over my background. I'm an electrical engineer by training, and I was focusing on signal imaging video processing. So I went all the way to a PhD that was in video compression. So I'm not very far away from home, working in WebRTC. What is fascinating about WebRTC is that it's made of different skills that usually you find in people that don't speak to each other. So you have people coming from the codec in part of the science like
Right.
me. You have people coming from the telecom, and then you have people coming from the web. And usually these three communities were not speaking to each other. So you will not find one course that gives
That's
you all the skill sets to actually master WebRTC. So I come
right.
from the codec side of the force, and other people that come from the web and the telecom are equally good. We just meet in the middle.
It's very multidisciplinary. Yes.
Correct. Yes, I agree.
Yeah. Okay. So how did that lead you to WebRTC itself?
Well, there is as always in a good story, there is a little bit of serendipity in there. I used to be in the academia, and I love the research. That means I love to focus on challenge and question that do not have an answer yet. And while in Europe there is a strong separation between the industry and the research that is supposed to be only done in the university, outside in Asia or in US, that's not the case. And I love to actually work on problems that do not have a solution, but also problems that are real world problems. So that led me to actually do a lot of round trips in between academia, university position, Caltech, Harvard, things like that, and startup. And so I was working for the government of Singapore as a public researcher on different topics. And at one point, I decided that I was too far away from real world problem, and I decided to go back into a startup. And at that time, way about it was 2011, 2012. Google had just done the first I/O presentation on WebRTC, and very very young startup, 2 people, 3 people, called Temesis, was looking for someone to assess WebRTC with respect in comparison with voice over IP. Is it smoke and mirror? Is it a real thing? They didn't have the capacity to assess. And so they asked me to take a look at that. Long story short, I ended up being employee number 4 or 5 of Temesis, CTO, and now I'm in a new startup still working on WebRTC. Though that's how my WebRTC adventure started. A little bit of serendipity, a little bit of good timing, the right skill set in the right place, a little bit of everything.
Okay. All right. Cool. So let's go ahead and jump to the big thing. So you've made some big announcements recently about testing, and there's something having to do with flying or air or something up in the sky, I
Yeah, I
think. Yeah.
think you're referring to the KITE product.
Yes.
So KITE is a very, very exciting project. In between my last 2 startups, I was working as a chief architect at Citrix. And across those 2 startup position and that chief architect position at Citrix, I kept working with the standard committee, and I was specifically reporting to the group on the state of the implementation with respect to the standard and the testing. And I saw both on the standard committee and on the industry, whether it's a big company like Citrix or small startup company, a lack of the correct tools for actually testing RTC in general, right? In the working group, that's the first time for web technology that you had a need for P2P connection. So a lot of the tool set were made to test what browser vendor call interoperability, which means in their mouth, the capacity of the website to appear and behave the same way, whether you run it in a given browser or another one, right? So if my website works and run the same and you get the same look and feel and behavior, whether you open it in Chrome or in Firefox, they call it interoperability.
Right.
For people coming from the telecom or for the internet but not the web, interoperability means you have two devices, or you have two things really. It doesn't have to be device, it can be people, it can be
endpoints, whatever, sure.
Communicating with each other and understanding each other, hence the interoperability. And so with WebRTC, the interoperability problem became more one of the internet kind than one of the web kind. So suddenly I need to be able to make a WebRTC call between Chrome and Firefox. And there was no tool in the web ecosystem to be able to do that. And so testing the spec, if only, right, to make sure that the implementation fits the spec and how much of the spec is implemented, what's the coverage in each of the browser, was an intractable problem. In the last technical plenary meeting 1 year ago, to compute the coverage, I had to print the specification on paper and go through the test line by line and actually, check each of the line in the specification to say, more or less we're testing that many lines out of the total document. So that was not appropriate. So that's the web side of thing. But when I was working at Citrix, for example, we did a lot of testing. But the most difficult part was the end-to-end testing.
Of course.
People on the mobile part had their own testing stack. People on the web part at their own testing stack, people on the media server has their own testing stack. When you put things together, what you really wanted to try is people from the web app, from, what was the name of that? GoToMeeting Free, right? That was the web app.
Right.
Calling people with a normal GoToMeeting, with a full native application, and everything that goes in between, all the servers and everything.
Right.
And that was difficult because people didn't have the same tool. There was not one tool that was allowing to do, any of those kind of call between two types of endpoints, two types of clients, right? And the startup had the same problem. At Temasys, when we started writing the infamous Internet Explorer plugin, then we had to test that thing at the same level as the other browsers. And we realized that, well, that's hard. Developing an Internet Explorer plugin is easy. Maintaining it in synchronization with all the browsers and on the release is difficult. So the value is in the testing and the maintenance, not in the development, right? So all of that mature with a lot of feedback from a lot of people from the working group, of course, all the browser vendors, but also Cisco, Ericsson, Citrix, all these guys, into a project that I presented last year. I presented the design of KITE at the W3C last year, and Google was nice enough to say, I think that's the right thing to do, and we want to be part of that project, and we're going to help you make it happen. So I actually did not make the announcement. Google did a few weeks back, because that's a Google-led project.
Okay, all right. So I'm curious. You mentioned that the different spaces had their own testing frameworks, right? So the browser vendors had a way to test just their browser, or test them individually, right? For the web, the traditional web functionality, and that in mobile there were frameworks for testing communication. I'm curious, what was it that really made you decide that there wasn't anything else you could start from? So you looked at it and you said, what, this is really, really unique, and I cannot begin with any of the communications frameworks that exist. I come more from the communications side originally, and we've been testing IVR systems, for example, in an automated fashion for quite a while. So what was it that was really, that you saw as really fundamentally different that no one had grasped and tried to address yet?
Right. So, you know, that idea about testing is not an idea really. It came from a pain, you know, as the original book said, there is no better project than when you scratch your own itch, right? So we were
Right.
really scratching our itch. That was really a pain we had. That was really a need, and that everybody in the working group and in the entire ecosystem, for that matter, had, and everybody was trying to do something about it, but nobody had cracked really the big problem. And so I did background check for 2 years on that internally at Citrix, but I reach out to Cisco to everybody say, how do you test that? What's your approach? What's the limit of what you have today? And we did a complete state-of-the-art study, right? And we actually published it 1 month ago with all the solution we could find, with all the links and everything. So people that are interested in the background work is there. And what we realize is that the problem was difficult to solve in a small scope and easier to solve as a generic scope. And most of the people were too focused on where they were. Let me give you an example.
Okay.
Google has adapter.js or has the WebRTC sample.
Right.
You know, and those have their own tests. And of course, they touch WebRTC, so they need to do something about it. Because they're using GitHub and because it's mostly JavaScript, well, they use the GitHub hook, they use Travis CL, and
Right.
they're doing testing there, right? Which is a traditional and totally normal kind of technology stack to test things that are in GitHub.
Right. Silo unit testing, essentially.
Correct.
Right.
And in that case, that was commit triggered, right? So the frequency is important. And that was limited by the technology stack. So Travis CL, for example, doesn't run on all the operating system you want to test. You limit it to 1 hour, even though that's not the bottleneck. And you can only run one operating system at a time, right? And so they were doing some tests, but each of the tests need to be constrained on one machine, one single machine. So you Alice and Bob that need to communicate, the two instances of your client that need to be on the same operating system. So let's say you want to be really thorough and test everything. You're going to want to test Safari against Edge.
Yes.
And there is not a single operating system that has those two browsers. So if you take the Travis CL approach, for example, well, you cannot test that use case. Some of the people started to say, okay, we can actually leverage browsers, right, that are hosted in the cloud. There are things like Browser Stack,
right,
that allows you to connect to the service and provide some browser for you to try. Well, unfortunately, they provide browser for the past. So the use case they're really trying to approach is, again, people that have an application and want to make sure that their application also run on older devices or older OS and older browsers, right? But if you, for example, a plugin developer or an extension developer for the case of the screen sharing, right?
Right.
You won't be able to use that service to test your development. If you want to test against early version of the browser, like the development version and the canary, to make sure to catch the bug before they go on production, you cannot use those services. So the difficulty is everybody was over-constrained by the use case, and all the tools that existed were so focused on a given use case that you could not cover all the cases with you. So, and then it came to me, okay, so what do we really want to achieve here, right? So here is what I want to achieve. What Google wants to achieve first, right? And then what people outside of the browser vendors want to achieve.
Right. The rest of the world that had the need too.
The question is, I want to test all the desktop browser first, and then possibly the mobile browsers. So I'm only interested in web app. If you're using a native app, that means you should use a web app. Right? So the scope of the project with Google is limited to desktop browser and mobile browser for the time being, which is already quite interesting. And there are some tools that do that. If you have one tool called TestRTC, for example, that does that pretty well. And I'll come back to that later, right? Now, the ecosystem, if you take people, company like Cisco, Ericsson, or Siemens with Unify, you know, everybody that has a framework to TalkBox, they will tell you, okay, web browser, yeah, interesting, but 50% of the people that connect to the internet, they connect on mobile through native app, right? So what happened if I got some of those hybrid HTML5 app? So I would love, for example, to support Electron. I would love to support Cordova. I would love to support this, and that. So at the beginning, I was telling you about the trigger, whether you want to be commit based on
Right.
GitHub and so on. Very simple, maximum 20 minutes, not to kill the efficiency of your developer.
Sure.
Some people want to do it daily, right? So you're doing during the night. You have 4 or 6 hours, depending on how long your developer sleeps and how much caffeine he had. Some people do it the weekend, and some models sometimes want to do a full run just before going on production that will run on parallel anyway on the frozen tree, so the developer are not going to push.
Right.
For me, that's one axis. Some solutions were doing very well the commit base, like GitHub and Travis CL. Some solutions were better for full run extensive. And then you had the client type. Some people only wanted desktop browser. That's kind of easy. Some people wanted desktop browser plus mobile browser. Okay, that's a little bit more challenging, but you still can do it. And then some people wanted that plus native application, including IoT, all right? So for example, working a lot with the automotive industry, and most of the panel you have in the automotive industry are based on Qt framework.
So you actually test, and how small can you go? I mean, IoT really could
Small.
mean, embedded device.
Raspberry Pi. We did a Raspberry Pi with WebRTC with H264 acceleration, hardware acceleration, on the Raspberry Pi 3. So, KITE was a tool that allows you to actually support all of that without thinking too much about it, right? There are other angle after, which is, okay, I want to be able to use browser stack for the very, very old operating system and so on, because I will never be able to have either a virtual machine or a physical machine for that. But in some case, let's say I'm a hardware developer of a game acquisition card or a webcam or things like that. Okay. I need a physical machine because I'm going to plug my hardware and check that it works, right, in terms of capturing actually the media stream, the audio or the video track. So there were some use cases where you need a bare metal machine to test the hardware and the drivers.
Right, you need a lab, a physical lab.
Right. Lab. But really, you never have a case where you can get away with only the physical machine or only the virtual machine, only ephemeral virtual machine, or only hosted. So we say we need to support all of those cases, and easily, right? So people can have, for example, on my machine, I have a beta version of macOS right now with a beta version of Safari Tech Preview for Safari for Mac developers. I want to add that to my test run as an additional machine. That should be easy. Let's say I'm modifying Chromium. I'm a Chromium developer. Let's say I'm an Electron developer. Let's say I'm developing a plugin. I want the thing that I just developed on my machine be part of the test run and run against more stable stuff wherever they run, right? Right. And we kept that also in mind when we did the original design of KITE, right? And so by doing a design that was more generic, we were able not only to fit each of the separate use case and do as well as they do, but also to cover, more than they could do.
So that would even allow me, within my organization, if I wanted to do my own customizations to a browser, that I would still actually be able to include it in this framework and do that testing.
Yes. Not only that, but Chrome nowadays is embedded in different things than Chromium.
Sure.
So you can do. It works with Electron. It works with Chrome embedded frame CEF. It works with NW.js. It works with a lot of flavors of Chromium that are used today to do native apps, right? Like wrapped web app into a native application.
Okay. So,
but most interestingly speaking, we separate the parts. The problem is that people were over-constraining the problem because they were assuming things, right? So we say, okay, the test should not assume anything about which client it's running on or which browser it's running on.
Okay.
So the engine should not assume anything about the browser configuration or browser version and so on. It just checks that it's here, and it does the load balancing of the test is being provided. It should not know anything about the test. So the test is provided as an input.
Okay.
The KITE, which is interoperability testing engine, right, connects to a Selenium grid that is also provided, and check the available configuration and prepare all the test metrics, and then run them concurrently. Not all the browsers and all the clients can actually handle concurrency. So sometimes running 4 Chromes means running 4 different machines. Sometimes you can run 4 instances of Chrome on the same machine. Edge, for example, in Safari can only handle one browser at a time. So there is a difference. So all of that intelligence, all of that knowledge is put in KITE and deals with it for you, right? It also doesn't know anything about the result, right? So the test is going to generate some results.
Right.
The engine is also going to generate some result, especially error message. If you have an error message when you connect to browser stack, it's really different than if you test run and the test generated an error.
Yes,
right.
And
you want to be able to separate those because they give you different information. It's not
sure.
The real failure is the failed test. It ran the way you wanted and give you the error of you were expecting. If the test is not run, that's a different type of errors. So what we do is the KITE is also taking in as an input a URL of a REST API where to send the result as JSON.
Okay.
That allows you to do different use case again. People that are just on a computer and running that and just want to see, we provide a very simple a web page and server, standalone Tomcat server for visualization of the result. But if you're a big company, usually you have your own continuous integration framework.
Right.
And you might want to pipe the result of that inside something else.
Right. So live.
And so that allows you to pipe KITE into a bigger continuous integration pipeline that can be whatever you want, because KITE is not assuming anything about the test. So the only one that really need to know anything about the output is the test itself. So the dashboard, so the next step in the pipeline, needs to know a little bit about the test.
Right. It's also live, right? I mean, that's the point, because you're actually sending the results as they come. You could have a process where you're watching it run live as well, and that may matter to you for the kinds of testing that you're doing.
Right. So you can think about any kind of use case, but basically we send a request, and we suppose that on the other side there is some kind of REST compatible server that is handling the results. Right. We're not going to try to we're not keeping them in KITE.
Right.
You can install locally on your machine that Tomcat server with database, and it's going to at least store the result for you. But we also have an output to the shell, right, to the standard output.
Right.
I really don't think you want to do that, because it's pretty verbose. Especially we have one configuration file with all the configuration we can make it work. That result in 2,530 plus tests being run. We don't want to read that on a standard output, but
sure,
technically it's possible, and just for the fun of it, we provide that little plug.
Right. Okay. So you've talked a lot about what it can do, and I'm curious. When you think back to your original need that you were trying to meet, which is pretty broad. So essentially you had several different needs. And essentially, you turn that into, well, basically we have one need, and that one need that everybody has is to test in all these different configurations, and that will cover everything. So I'm curious, how do you think things have turned out so far in meeting that need? Yeah.
I think we're pretty happy with what we came for. The first goal was to show that handling that huge matrix of configuration with different operating system, different browser, could be handled automatically. So what we did is we took a very, very simple test, because the test was not the focus, and we took a very, very simple system to test against. So namely, we took WebRTC and a one-to-one audio and video call. That was it. And we were just checking if the JavaScript ICE connection state was moving to connected. Which, as everybody that did testing of WebRTC know, is not even close to enough. But the idea was to show that test, against a live WebRTC on the web, can be run on an arbitrarily complex list of configuration without a blink.
Right.
Without adding complexity to the test, or without adding complexity to the system being tested. because we want the engine to be able to test Spark, WebEx, Duo, Allo, everything out there, right?
Sure, sure.
That was the idea. So, and that was pretty well validated pretty fast. Within 3 months, that thing was validated. So now, what is interesting is the state, the maturity of WebRTC, right? I remember when we were first talking, having a first one-to-one example working was miracle. You know, there was an opportunity for popping some champagne.
Yeah, right.
Today, having a one-to-one call is, you know, it's business as usual, even too easy. So nowadays, people, originally, I remember 20 to 25% failure just on connection, on the highs and shake and things like
Right.
that.
And by the way,
according
that originally
Mhm.
was just a few years ago, even, right?
Yes.
We're not talking 2012. We're talking about even, 2 years ago, maybe even shorter than that.
2-3 years ago.
Yes, right.
Right. So I'm following callstat.io because they have really good stats on that, and I think they have enough volume to be pertinent to represent. And I don't think there is a better alternative out there anyway. So the latest number they showed in Beijing 1 month ago was around a few percent. So the problem of connection now is pretty well understood. Now the problem we might have right now is with quality of the media, is with multi-party, and then there will be the upcoming simulcast and multicast and things like that. And that requires a lot of testing because the complexity of the test is much higher than testing just a one-to-one connection. So now that the engine is stable, really the next step is to start having much better tests, so testing much more, implementing regression testing, so getting GetStat and make sure that the tests run at the same speed, as the time go.
Sure.
And supporting the latest API, not only to help the browser get it right? And that's why Google is involved.
Right.
And Google, Apple, Microsoft, everybody, right? But also for the people that want to test their application in more drastic configuration. Right.
Okay.
So now, in terms of the original goal, which is okay, no, the problem is that I might need 2 different operating systems with 2 different browser and 2 different browser revision, and some people use Windows 7 and whatever. For me, that's already solved with what we have today. And now we're going in more complex tests in more control environments. There are a lot of things that can only be tested if you fluctuate the available bandwidth. And there is a very interesting European project today called ELAS-Test, which is an emanation of the Currento test framework that is actually working on things like that. They're on the way, they're doing a very good job. Everybody interested in testing should take a look. I think they will have interesting results. But the idea is the ramping up of the bandwidth at the beginning of the call, the bandwidth adaptation when suddenly the network goes back.
Right.
This is what eventually makes the difference in the perceived quality of a call,
sure.
Right? Whether there is jitter, where there is delay. And so if you only base your evaluation of the quality on the result of GetStat, which are network level statistics, it doesn't correlate so well with the human perception of the quality. So we speak about objective metric as the one that can be computed by a machine, and subjective metric, which is the score a human being will give to the call at the end, if you like, give 1 to 5 stars. So I think there is still a lot of things that can be done on the objective metric, right? So try to fluctuate the network and see if you can do that in a deterministic manner and see if things happen the way you want it. And then there is a lot of, everything is open in terms of subjective metric. So there have never been any research in terms of subjective metric for real-time communication. Netflix did some research last year in 2016, but that was on broadcast, which is very different from the real time. Like you record ahead of time, you compress ahead of time, you control everything. There's a lot of things you control. When you do real-time communication, you don't control as much. And so we are doing a little bit of research on the side as well on artificial intelligence applied to those metrics to try to be able to have a test, have a demo and a software that would be able to score a given call as close to what a human could do in terms of subjective metrics. So if you were giving a score of 9.8, it would give a score between 9.7 or 9.9. But of course, it could do it at scale.
Right.
right? And
Right.
the thing we see moving the test from a binary test, is it connecting or not,
Sure.
to, okay, no, it's connecting all of the time, but is it of good quality or not? What happens if I want to go higher resolution? Can I sustain it? What happens when the bandwidth goes down? Does it handle it? Or well, does it handle it? So that's where we're going to spend a little bit of time. I know a lot of people are excited about VR and AR. We are. But at the end of the day, I think we just codec people that love mathematics and signal processing. So we're going to go on the other side of the force.
Well, you just want to make sure that the core is working the way people expect it to, right? I mean, that's I think where you started. You started with the fact that people just had no idea whether it was going to work, right? Whether it was going to work, and it can mean the browser, it can mean the communications channel, etc. And so that's kind of an obvious extension. So I'm curious, in this process, obviously things are still going on, right? As you say, there's a lot of work still to do and a lot of exciting stuff to do. Were there any parts of sort of this process that went better than you expected? So you were surprised and like, oh, that was actually easier than I thought it would be.
Um,
And I'm talking about the process of building out this whole infrastructure, framework, etc.
we were really concerned about the maturity of WebDriver and Selenium, especially outside the browser world. And that was, I think, with the insight, a fear of the dark. After we did the homework, we saw that it was actually not that difficult, perhaps, to extend beyond the realm of browser. We were also very, very afraid of starting to test multi-party and load testing and things like that.
Right.
So, of course, the engine is removing a lot of the problem, which is scaling the Selenium grid. But we were not too afraid about that. We were really afraid about multicast in WebRTC. Unified plan, plan B, and
Yes,
so
right,
on and
right,
so
right.
forth. That's still in flux, right? So, but if you make the right choice in the beginning to focus days along, and here I want to publicly thank the Jitsi team at Atlassian. They're really investing a lot of time to be compatible with Firefox and Chrome, and they stay very, very close to the browser. So it makes it easier to test the browser with their system, because their system is already very, very close. And they're doing an excellent job there. So we started testing multi-party with them. They had already made a scheme available for Unified Plan, Plan B. They had already tested all the easy case and so on. And eventually that ended up being much easier than we do. So kudos to the GT team. They really did a good job there.
So that helped you a lot. That's
now
good.
I'm still afraid. Again?
That helped you a lot. So that's good. Yeah.
But I'm still afraid about the upcoming object model API and the simulcast, the real full simulcast case in the spec. And I think I'm not the only one. I think the browser vendor are like that. I was speaking with Bernard Aboba from Microsoft, and was telling me, you know what? The one-to-one normal case and everything, whether it's ORTC or WebRTC, I already got it cornered, right? I can handle it. I'm testing it. Okay, there is no problem. I don't expect any surprise there. Now, the problem I have is really with the simulcast in WebRTC.0, because then you introduce an SFU. And most of the tickets I get from people that complain about it not working, they don't say WebRTC is not working. They say it's not working when I use Janus. It's not working when I use Curento. It's not working when I use Jitsi. And you get different kind of errors depending on which SFU you use. And so there seems to be, first, a lack of reference SFU implementation. We would have complete spec around. And I think in that respect, this is not the same problem with Turn, where the CoTurn project is really good, really a reference, and there's only one, and that's it.
Right.
And that also shows that we need to test much more that use case, because there's still a lot of error out there that might not be visible yet by lack of proper testing, right?
Right.
So that I'm a little bit afraid of. That means, writing the test against all these platforms, running them, collecting, I expect to find a lot of surprises, especially at the beginning. Thankfully, there is a lot of good open source SFU, and most of the team are not only very knowledgeable, but willing to help and participating in the standard as well. So I hope really that now that the tool is available, that we're going to see a speed up in the maturity of the standards we all want to see finish and be able to use as soon as possible.
Right, right. And you're right about the lack of a reference implementation in sort of that space. There, anytime you talk about communication, you have to care about both sides, and so the discussions have all been on the browser side and not on that SFU side. But thankfully, there are experts there working on it. So I wanted to ask. So I think there are many people who need testing. So if you're somebody who's just getting started with WebRTC and some things don't work the way you say, okay, I'm going to build my own app, and you build your own app and you go, wait, this doesn't work. Oh crud! I need to test this and see which browsers support this, which browsers support that. What is it that's working? What is it that's not working? So you know what's you and what is someone else. If they asked you how to test WebRTC, so they just say, surely I can test WebRTC. I'm sure the simplest answer you might give would be, well, call me and let me do it. Okay, but is there any advice you might have for someone who wants to start on their own? Don't.
Okay. How can I test WebRTC is a very broad question. So my first answer to the guy is like, define exactly. And drawing is winning. We have that game back home. In that case, drawing is really winning. So draw the different pieces of your architecture and say where you want to test and from what perspective. If you keep the scope too large, you're gonna fail. The second thing I'm going to say is that a lot of people have been there. So do your homework. There's a lot of fantastic blog posts about how to test different parts. When you have identified which part, or even before it, if you write testing WebRTC blog post right on Google, I'm pretty sure you're going to end up with some very good blogs. There are a lot of them in WebRTChacks.com, for example, that we still use as a reference and I give to my new employee when they ask questions. Sometimes they're really technical, but not always. And it's always good to do your homework before you start, just if only to narrow the scope to what is really important to you. The second thing I would say is WebRTC can look very, very easy. You can do your first demo in 1 hour with a one-to-one call and it's beautiful and your mom is proud. But outside of that one-to-one path, you're alone in the jungle, right? And again, you're not the first one that has been there and you're not alone. So if you don't want to bump into beginner errors because you don't know better, you have some projects that are here to make your life easier. If only one, use adapter.js. If you have a web app, right, or a web app wrapped in React /CEF/Electron/ whatever, use adapter.js. It's going to cover the first mistake you will do otherwise. And those are painful ones. The first one are usually the one that takes a long time to understand, right? And if you still have some problem after you use adapter.js, that's where you need to get the heavy tools out. So what we propose with KITE, whose core is open source and free, like beer, by the way, is but one tool, right? But it's like a carpenter. You don't see a carpenter doing his job with only one tool. He has the tool for the border, he has the tool for the big frame, he has the saw, he has different tools serve different purposes. So it's good to identify, and I think on webrtc.org there is a page that starts to do that, different tools that are available to you to test and assess different parts of WebRTC. Is it the bandwidth? Is it my ports? Can I have a network diagnosis that the remote guy can actually use? And so the answer is yes. All of the above already exist, have already been coded. There are always one or two free implementation you can start with. So before you reach the need for a consultant or the need for specialized tool, there is a lot of things you can do already, right?
Okay.
So remember, read and look, understand, because this is a complex matter where, again, you have telecom, you have web, you have codec, you have a lot of things coming in. It's almost impossible that you know all of them.
Right.
And even after many years working in it, we don't know all of them. And that's why we all work together, because someone is better at testing the network. Wireshark is an acquired taste that I still need to acquire. I have to be honest with you. But then when I speak with my telecom guy that can do Wireshark with his, blindfolded with the right hand attached behind his back, when I speak to him about H.265 codecs and entropy and things like that, I could speak Chinese to him that would be the same, right? So, go around, find the right people. There is a lot of meetups. There is a lot of documents. Don't start right away by saying, how difficult can it be? Let me run a test.
Sure, sure. Okay. So, what's next? Is there anything that you're excited about or that you think needs addressing? I mean, you talked a little bit about the direction you're headed, but is there something more that that you're thinking about for the future or excited to think about? Or something that keeps you up at night? I mean, it could be like, oh, shoot, what about this? You told us some of that. Just is there anything else that you'd like to mention?
I'm still stuck at the last boss of Zelda on my Switch. That's keeping me up at night from time to time. But as far as KITE and WebRTC is concerned, I think KITE, we're really happy of where we are. We're really happy where it's going. We have a roadmap that makes a lot of sense, and we have a lot of backing from the ecosystem. So we just need to execute and focus on the roadmap, and we're good. In terms of WebRTC, I'm really excited about seeing SVS, right? The SVC codec coming in, VP9 SVC. Again, I'm a Connect guy, so that excites me more than the other stuff. I'm lucky enough to have a team that share that interests. So I'm working with a guy called Sergio Murillo, who just wrote a blog post on VP9 SVC. I think there is a big interest in double encryption, more than people realize, for very, very specialized, but actually quite big segment of the market. You think about financial institutions, think about government, lawyers, hospitals, and so on. Even if the
could you just say a bit about that? I'm sorry, just briefly say a little bit about double encryption and what that is.
Right. So there is a working group right now at IETF called PERC for privacy enhanced RTP conferencing, right? And they're trying to come up with a template for dealing with double encryption on top of RTP conferencing, which specifically encompass WebRTC and SIP, right? That's really the two biggest application right now. And it's still in flux, it's still being discussed. And that's actually a mandatory thing for people working in the financial industry and in some other sector of the economy, and lawyers, hospital have a different regulation than the banks, obviously. So you hear a lot about HIPAA, for example, and WebRTC Venture is really good at doing that. But in terms of pure double encryption for banks and stuff, I think we're one of the few company with Cisco and a few other that is focusing and has an existing implementation in place today. And we're trying to move the standard along as we do the implementation, right? To play nice with our neighbors. That means also having a modified version of every single browser, having a modified version of Qt, of Electron, of everything with double encryption implemented in it, and testing them again.
Right.
So that's why KITE is very helpful for us to develop new technology, because we have the capacity to test it extensively right away. So that double encryption is something that is super cool. The W3C just made a decision that didn't make everybody happy, I would say, to accept DRM, right, for streaming content into the browser.
Right.
And now that opened the question. Let's say people want to have their own crypto module. People want to use bioinformation, or they want to use hardware-based encryption for more security. Should we allow the crypto module in WebRTC to be pluggable, just like it was allowed for the normal streaming, for example? That opened a whole new world of application right there, where we don't assume anything about the crypto of the application. I actually have a lot of people that came to me interested with that specific use case. I think they're going to show up at the next meetings of PERC and everything. So we're pretty active there. Other than that, the global goal of what we do here in Singapore in my group is to make WebRTC easier to use and embed, right? So make some tools, make some installers, because compiling with WebRTC is still kind of black magic outside of Google. And so we think that the market is mature. I mean, between 2 and 4 years ago, a lot of people say, I don't know if I need WebRTC. Nowadays, people are more like, I don't know if I will ever be able to embed WebRTC because it's hard, you know, when you're not in a web application and so on. And when they succeed, it's like, well, I need to test that thing more. So we're trying to make everything easier through different angles, but that actually complement each other.
Okay, all right. Is there anything else you'd like to tell us? I mean, I kind of directed things towards KITE, but and you talked just now about all the other stuff that you're doing. Is there any last thing that you're thinking, oh my gosh, I wish you would have asked me about this, because this, I'd really like to mention this, or did we get everything?
No, I really think, you know, I'm trying to react to the pain points that I've seen for the past years with different people. So of course, it's very biased because I didn't meet everybody. I think if people have a specific pain points, especially in the C++ code or relating to codec and things like that, they're always welcome to contact us. If we're not able to answer, we usually connect them to the right person, because it's a small ecosystem. We have a good relationship with every other consultant or product vendor or application development shop out there. One of the other research, well, you know, kind of quote research project that we have for next year is to develop more codec support for LibWebRTC. So Google has just changed the design of LibWebRTC to support injectable codecs, external. So it's easier.
Right.
To actually put one, but to be able to be injected, there is still a little bit of work to be done, right?
Sure.
And so, for example, I was speaking with a Vietnamese telecom operator that said, you know, I want to do audio only, and I want to do J929, I think, or 729. Which is an audio codec that went into the public domain not so long time ago, so that is completely free to use, but that Google already announced they will never support. They will never put in WebRTC. And for them, it makes a huge difference because they don't have to transcode. So that means they remove a gateway, they remove delay, they remove everything, because the client can directly send the right codec. Whatever you think about the quality of that codec, it has, you know, a big impact on the design of the backend on the other side. You know, things like that. People want to H.264 with some extended profiles. Some people want other stuff a little bit more exotic.
Right.
So we have the capacity to make that happen, and we want to make it models. We want to go to the point where people go to a web page and they say, I want a LibWebRTC installer for Windows 10, 64-bit, debug please. And here are the options. Do you want double encryption? Yes, please. Do you want the 265 codec? Do you want this codec? Do you want? So you click, and then it compiles it for you and send it as an installer to your email address. So I think we're 6 months away to be able to do things like that.
Okay. Well, I look forward then to interviewing you again, and you know, hopefully maybe if you have some follow-up articles, you know, there may be follow-up topics that you'd love to come and talk to us about.
I would love to do that.
All right. Thank you very much. It's been great talking with you, and look forward to speaking again. Thank you.
Thank you, Dan.